Hello. I already tried to record this once, but it ended up being a 20-minute recording, which is a little too long. So I'm just gonna try to do this quickly and maybe in a little less detail, and hopefully that'll turn out okay. So the first thing I did for our Halloween project was make the whole system for getting the panels to work. So like in here, how you can pick things up and put them down and eventually interact with the door, blah blah blah. um, Basically, we wanted a system to have that layout. That was kind of our original idea. And so I kind of took it upon myself. Craig also tried to do his own implementation, which was a little more UI heavy, but would have used, I think, images of the 3D objects, which was a little less dynamic feeling, at least to me. So basically, the way I did it was by using a whole bunch of math. I knew that this was possible in Unity, so Craig kind of introduced me to the concept of these scene capture components that render to the render targets. And Unity has a similar concept with you can just get any camera to render to a to a texture essentially. So basically, I use all this code here to, I have the image's location on the screen, and I get the mouse's location relative to that from a range of -1 to 1. So basically, I just know where the mouse is on that. I check if the mouse is on the image. And then if the mouse is on the image, I do a whole bunch of math. So this math here and here is to accommodate the field of view. So if there's a different field of view of the camera, then this math here is because of the way aspect ratios work. So we can assume x is always going to be 1. So like this distance here is always 1. And then this distance here is whatever ratio this is to that. So whatever ratio y is to x. And we have to accommodate for that. And then we get a vector from that based on the direction the camera is facing. We multiply that vector by a really big number to make it essentially infinite. And then we start the line trace at the scene capture, end it at this point, and then I just move a sphere to that location. That was a debugging thing, but Craig ended up using it in his thing for picking things up, so we just kind of kept it in here, and it'll also return out all of the camera trace stuff, which is good. Next thing I did was when we first set up the little 2D scene over here, Anna set up all the sprites and everything. It looks very nice. She had like a little thing here that showed a little bit of light coming off of the door, and I'm going to press play right now just to show that off, and I'll show off a couple of other things while I'm at it because it takes a second to get there. But basically, the first thing I ended up doing was this blueprint, which just takes the current rotation of the door as a normalized value between 0 and 1 and applies it to the animation, which will be shown here. So if you look, as I open the door and close it, the light kind of corresponds with that, which I think is a pretty cool thing. So then there's also this book which I can show off, which I made, and you can flip the pages and the arrows disappear, and you can put it back down. And that's kind of most of what I did for the main gameplay. So if we go over here, this is, oh, let me just, that's not good. Okay, here we go. So then if we go over here, this is the outdoor child blueprint. So essentially it gets told whether or not it's a vampire, but I have to wait a tick to do that. Then it assigns a series of behaviors using kind of a brute force method to do that. Decides where it's going to stumble while leaving a gap where the tree is on the thing, because if you look here, if there was someone stopped in front of here and they stumbled, you wouldn't really see it, so there's just a gap there, and then a distance to follow the next person. Then we get all the people, filter out all the people behind this current one that like is this object, and then find the closest one based on that list of kids in front of them, and that becomes the kid that is in front of them that they stop before reaching. Then in this state machine, we're just switching on all the different states. Most of them are just to set different flipbooks. In some cases, like with running away, it destroys this object but then creates a new object. And then this is another switch statement, which is just based on what happened if you put something in the doorway. So if they knock, so this is the knock state, then Craig spawns in his kid, and then his kid will eventually tell my kid what has happened and how they should react to that. Um, then I have a bunch of stuff in this tick event, which is just for like, if they're at the door, they should do their knock thing. If they are idle and the kid in front of them is far enough away, they should start walking. And then if they're walking and they're at their stumble point, they should stumble. And if they are at the if they are close enough to one of the children in front of them, they should stop walking. Then this is the child spawner, and it just uses a timer by event of this spawn child event to spawn in a variable amount of children. I set the desired amount of children on this child loop event, and then basically I tell it that it's looping, and then if we have the desired amount of children, I tell it that it's not looping, and I clear the timer. And this just makes it so that if a child is walking away, where did I put it? Anyway, it just makes it so that, yeah, child loop, I can just spawn in more children, and it'll always be a queue of 3 to 6 children. So sometimes, even if this is called, it won't spawn in any more children because it's at the current cap. So then this is for when the child wants to walk back, and it just essentially spawns in this walker blueprint, which I have here, and it just moves the blueprint over until it reaches a point and then destroys it. And it does this at like a slightly random speed in a direction set by the user. And so this essentially just simplifies the system of not having to like manage whether or not a child is currently like validly within the scene or not. And then this vampire death is a similar thing, except it there's like a tally of vampires, and if that tally of dead vampires gets above a certain number, we win. And it also just tells all the children to run away if a vampire does die. Then this is the blueprint for the book. It was very simply made because of the lovely artists who put it together. So it was essentially, this stuff is just to pick up the book and put it down, and it just lerps it between 2 different transform points. And then for flipping the pages, I just set a number to either 1 or -1, and that's the speed of the animation. And that speed just flips back and forth, and I play it, and then if it's on one page and I flip it backwards, it'll go to the other page, and so on. So it's just kind of cool from that perspective that it was just so simple to put together, because everything was already like put together on the art side. The moon timer is just a very simple timer, and then I move the moon between a start point and end point that I picked just in the scene. And then I have this other lerp, which lerps based on a curve for the Z direction, so like up and down. And basically it just does all this based on the amount of time out of start time. And then if you, or the amount of time out of a max time, and then if you get to the end of the game, or like get the timer runs out of time, you get to an end screen called out of time. This is just, the artist did a whole bunch of art, and for some of it, it wasn't set properly to UI in the texture group, so I had to set that in a few of them. Not a big thing, but just wanted to mention it because, I don't know, feel like that's something they should know how to do. No shade or anything. This is our main menu blueprint. You can see here, Sophie designed all the lovely art we have here, and I kind of threw it all together and made this like custom teeth animation that you'll see when you play the game. And I don't recommend doing it the way I did it. I'm not sure if there's a better way to do it, but I have to imagine there would be. But basically, for every single button, I have to do the same, like on hover and then on press and all this stuff, which ends up being kind of annoying, but you know, it looks cool, so it's probably worth it as far as I'm concerned. Then we have these two, or I have a fade in and a fade out blueprint. I don't have both of them anymore open. But anyway, I kind of figured out that you can put blueprints in other blueprints, or not blueprints in other blueprints, but rather blueprint widget blueprints in other blueprints. And that kind of helped with getting all the fade ins and fade outs really easily within different scenes. So like all the end screens have it, and the main game has it, and blah blah blah, because originally I had done it in here. I did like this thing slides down, this specific box, And I did that in maybe the stupidest way, which is by just lerping, because I seem to love lerping things. But it turns out you can just use animations and like drag and drop them, and it's really easy. And that's I think everything I did. There's like some other minor things like helping out with, collaborating with Craig, or helping out Quentin look through our code and figure out where to place all the sounds. Um, but like generally, I think I covered most of what I had. I'm not sure if I mentioned, but I think the first thing I did, which is this panel test, was my heroic contribution. And yeah, that's about it. Thank you so much for listening, and that's about 10 minutes.